Thicknesses of double-sided circuits vary a little bit. Here's a cross-section of a typical flex circuit, and you can see from the top down you have a layer here that's called the cover lay, which is the top dielectric that's comprised of polyimide and a acrylic adhesive. Below that, for double-sided, you'd have a panel-plated copper layer that is actually plating the barrel as well as the surface of the foil of the copper. And that copper is bonded to a base film with another acrylic adhesive. And then you have the opposite side on the bottom for double-sided. And so the thicknesses vary a little bit, primarily due to the copper thicknesses that are being used. But for this example, we're going to assume that the base foil copper layer, shown here in light blue, is a 1 ounce copper, which is defined as the weight of a copper sheet 1 square foot, and it's called 1 ounce copper. And so the thicknesses are shown here, and you can see that there's a 1 mil polyimide film with a 1 mil cover lay. That's 2 mils in total. Plated copper is typically 1 mil thick. Copper foil itself is 1.4 mils, and then the base adhesive is about 7/10 of a mil, and that's on both sides of a 1 mil film. That's pretty typical. On the other hand, if you had thicker copper, then what needs to happen is this layer here of the adhesive needs to be thicker. Potentially the top polyimide could be thicker as well for higher dielectric strength. But that adhesive layer needs to be thicker because this copper is thicker, therefore the adhesive has to flow in and encapsulate around the conductors in the spacing area. But you can see for this example, this is a double-sided circuit that's about 11.2 mils thick, or 11.2 thousandths of an inch thick. This is an example of a single-sided circuit where you would have one layer of copper, and in this example it's 1 ounce copper. And typically with single-sided circuit you would be designing it to be as thin as possible. And so in this case we have a cover lay, which is comprised of a cover film and the acrylic adhesive, and the base copper, and then the base film, and that copper is bonded to that base film with an adhesive. And so the thicknesses here are the cover layer are about 2 thousandths thick, and then that base circuit is 1.4 mils, 7/10 of a mil, and then another base film at 0.001. So the total is around 5 thousandths of an inch. If you were actively designing this to be as thin as possible, you could reduce the copper to a 1/2 ounce copper, and potentially even go with adhesiveless construction, which would eliminate this adhesive as well as that and bring that down even further. But one thing to note here is that it's typical that you would also have PSA on the back side of some or a good part of the flex circuit as well, and that would add 2 thousandths of an inch to the bottom side of the overall flexible circuit.